In part two today, we're going to talk about the practice. So what actually happens with precast concrete in practice. And it's looking at some real world issues because it's based on a project I've been involved in the past couple of years. And as I mentioned last time, I don't pretend to be an expert on precast concrete. So these are just my reflections on my experience of precast concrete, some good, some bad. It may even be not so much an example of what to do, but an example of what not to do. And if I was doing it again, I wouldn't do it this way. So yeah, the tale grew in the telling. Basically, I've been putting together slides for the past year, but this is the first time I've actually ever presented this. So this is brand new. So never done before. Let's see how we go. So as I said, there's an old joke, particularly in Ireland, that a lost traveller was asking how to get to Dublin. And the local said, well, if I was going to Dublin, I wouldn't go from here. So if I was going to study precast concrete and tell you all about precast concrete, I wouldn't start from here. The project I was given, and it was in the state it was in, and I didn't really have a great deal of input into the original design of the project. It was a design and it was turned into precast concrete. And so I was there to do the construction monitoring. So a rundown of the contents for today's presentation. Well, we mentioned last time the construction sequence is very important, as well as construction management. What are the construction components? Well, we'll briefly look at some of the big ones like shell beams, flat slabs, and wall panels, and then look at the production process. So how do these things actually go together? So what are the issues? We'll come to towards the end of the presentation. And obviously rebar congestion and what happens if something goes wrong. There's a nice little thing called mistake plates. These panels can get damaged and sometimes they're not quite as nicely made as we'd like them. The starter bars can be in the wrong place and the vertical joints and the horizontal joints can give you problems. How do you stack them? How do you store them? And what happens to the finishes of the concrete? And sometimes you get things you've cast in which you can't use. And finally, list again the secrets to successful precast construction. These are my kind of secrets, not really secrets, but these are the conclusions that I've come to. Others might like to contribute as to how they think precast concrete could be done better. So here's an example of a typical construction sequence for precast walls. The first thing you need to do is check the location of the starter bars on site. And ideally, you should provide the precast contractor with a template of the starter bars. Now, what is a template? Well, it can simply be a piece of plywood cut to the right size with holes drilled in to show where the starter bars actually are. And then you can take that to the precast concrete manufacturer's site and use it as a template for setting out some of the dross backs or the grout sleeves that he will be casting in. An important point to note is put some notes on the template which say what is the wall for and what's the wall number or reference and which way up it goes. So off-site, you fabricate the precast panel. It comes to site, it's delivered, and it is erected into position. You need to prop the walls. You need to base, dry pack and grout up the base, and then grout the ducts. Cast the in situ stitches, so where you've got joints, one wall meeting another wall, you can have an in situ stitch between the two. Fix what we've called steel plate connectors. So some of these vertical joints have steel plates connecting them. Once all that's done, you can then go on to construct the next level. So that starts with fixing the steel support angles, placing the planks, precast planks in our case, and then add the slab rebar and cast the concrete. So this is an example of precast concrete use of precast panels plus the precast planks. Now, there are obviously different variations on this. This is just one example based on my experience. Important to note is the construction management, and it's nice to have a template. This is what I prepared earlier, and it's simply based on Excel. So we open that, the larger Excel spread out. So what's the items, what's the activity? So one of the items was laying the shell beams. What sort of equipment do you need? Who is the subcontractor responsible? What's the delivery date for them? Start date for the erection, and hopefully the end date for the erection. And then there's checks on each of the components. So obvious one is setting out the lines and level of the component, in this case the shell beams, and check the delivery condition. You know, is it in the condition you expect it to be, or has it been damaged? And once it's on site, in place, you can mark it as complete. Now, some of these things will need a sign off from an engineer doing the construction monitoring phase. The floor slabs are a bit more complicated because you've got false work and formwork and propping to go in, as well as steel support angles and so on. And on the right-hand side, you can create a little project plan and put it against the day. So this is a very simple Gantt chart if you wish to create one. And you can repeat this at each of the levels. So this is a template for level 1, then similar thing for level 2, and so on. One of the key issues is deliveries, because many sites will be congested and you have limitations on when you can deliver and where you can deliver your items. You'll also have limitations on the craneage. So precast concrete construction is very dependent on the crane or cranes you have. So let's see the visuals. This is what it looks like on site. So these are a number of precast concrete shell beams. And they're called shells because they're empty shells, basically, for more rebar to go in, as you can see in here. And these bars tied to the side then get bent down and folded into the slab. They will need to be propped in the temporary condition because they are part of the final scheme. One of the issues is trying to get services in. So on your, let's pick a point. Hopefully you will get them in before you make them. So there are ducts going through some of these beams, and you need to allow for those by casting in ducts for their future incorporation. Here's a wider view of these shell beams, and now we have the precast planks come in. Now, both of the shell beams and the precast planks were manufactured and supplied by Form Stress, and they can deliver quite a few of these components at the same time on a delivery truck. And so then comes the problem of how do you store them on site? You do need some laydown space on your site, so you can't always put your components, your planks and your shell beams in position as soon as you can. Ideally, you would like to take it straight off a truck and put it into position on site as soon as possible, without this double handling or triple handling in some cases of storing components on site. And again, closer look up of the precast planks. So they simply sit on the edges of the shell beams, and the bars coming out of the sides of the shell beams then get folded down. And we get some reinforcement on the top and a concrete topping. So they stitch the whole thing together. Here's an example of a shop drawing. And this is a relatively simple example. showing as much as we can, everything we need to show for the precast concrete manufacturer to build the panel, and nothing more. And so here are all the bars that are going into that panel, and any cast-ins. So these little dots here, zoom on there, these are cast-in inserts. So into the production, here is a casting bed, and the rebar cage is assembled and put onto the casting bed. The casting bed is heated, and so you get accelerated curing of this concrete, which allows you basically a 24-hour turnaround from casting the panel and lifting up and potentially bringing it to site. To lift the panels out, we need to put in lifting eyes. Here's one example. This is supplied by Reed, and it's a hairpin, basically, a hairpin anchor, which is cast into the panel top with what's effectively like a rubber block out, so you can get to this lifting eye here. These are the grout sleeves mentioned before, the reed bar grout sleeves, which you epoxy the reed bars into the top of them, and the starter bars come in. Scroll it. The starter bars come in from below in there as well. So obviously casting the concrete, the precast yarding is usually large enough to allow a full concrete wagon to come in and pour directly onto the casting bed. The people on site obviously need to compact the concrete and then finish it off. So we finish in this case with a float finish, a simple troweled finish, and then they can lift it out. A point to note here, all the lifting eyes you put in, they may not necessarily use, but then they lift it out and put it into their storage rack for potentially tidying up, because sometimes they need to do some repair works before it's shipped out to site. On site, it comes in and off the truck and lifted into position. And once in position, it obviously needs to be propped. Now you're propping against usually your existing construction, your existing slab in this case. Now, many of the props can get in the way of you moving around the site, so it's quite important to plan where you put the props. It's doubly important when these internal panels are either 2 stories or maybe even 3 stories, that you've got nowhere to bring your prop back down to, and it will interfere with the next level. So examples of propping again, but here's where we get into our joints. Oops, sorry. Into our joints here. So that's a cast in situ. They add a little bit more reinforcement and then pour in the concrete with that. At the bottom end of the panel, you have these dross backs, and those dross backs have grout tubes, and those grout tubes need to be grouted up. You squirt in the concrete from the bottom and wait till it pours out of the top. It's a very simple and messy operation. In this case, they're using an electric pump. I wouldn't recommend trying to do it with a hand pump. It just simply doesn't work with a hand pump. You need a decent pump and a decent hose and a decent nozzle, and preferably contractors who know what they're doing to put that grout in. The point is that the entire integrity of this wall, and therefore the integrity of the building, is dependent upon making this grout fully fill the grout sleeve. And so the vertical joints, the panels can be joined together with, in this case, steel plates. And then we've also got our shelf angles for putting the next level on. So here's some typical reinforcement. A typical shop drawing, nothing too bad here, because it's a relatively lightly reinforced. And again, I'll zoom in on that. We have our cast-ins, which shows that we've got 8 RBA10 threaded inserts. TF is the trowel face, and there's a great deal of confusion about which is the trowel face and which is the mold face, and that's caused all sorts of problems with our project. So MF, if you see the figure MF, might not mean what you think it means. It means mold face. And so if you're drawing these shop drawings, make sure you draw it such that the mold face is at the back and the trowel face is at the front. So in effect, your mold face is the far face and your trowel face is the near face. It makes it much easier to check when you're checking these panels in the precasting yard to check the reinforcement in the right orientation. Usually the critical thing to check is the setting out of the starter bars. So I'll zoom in on that. The setting out the starter bars are marked here, and the precasters like to have running dimensions on each side for each of the grout sleeves in this case. And so similarly, if you've got bars poking out of the top, you'll need running dimensions for those as well. So that's a nice simple one. A slightly more complicated one is on our next page. And again, I can criticize this because I drew it. Part of the reason this is so complicated because the rebar is so complicated, it's very heavily congested. And you can see I've separated the vertical bars from the horizontal bars. Down in the bottom corner, we have our reinforcing schedule. Make that a little bigger for you. And we end up cranking some of these bars in the spandrel panel as well. So we need to give the dimensions for those. And this is what happens in the yard, and some congestion of your rebar. There's a little hint here. If your rebar looks that busy, perhaps your walls are not thick enough. And similarly at the other end, you've got grout sleeves, and these are quite close centers. And again, if you need grout sleeves at these close centers, your walls are too thin. Basically, you need to do something else. And sometimes mistakes are made. Sometimes the lifters don't work, or they can get pulled out or damaged. And they can use this thing called a mistake plate. And it's used to bolt. It's bolted to the face of the panel to allow you to lift it up as well. And many of our panels are getting damaged or were getting damaged. A lot of this is due to transport. If you slap these panels on a truck and put it over the bumpy roads of Auckland, the chances are they're going to get damaged. There's damage potential when you're lifting it out of the mold, damage potential when you're putting it on a truck and taking it off a truck. So it's important to pack out your panels with plenty of timber packing or dunnage, so it's protected. And particularly the corners are very vulnerable as you're lifting them out and putting them into position. Obviously, these will get repaired as well. This was an extreme case of a damaged panel, and this was because there's so much packing out, too much packing out for blocking out for these grout ducts. This was eventually repaired and put back in properly. And you can damage it by trying to attach things to it. So if you, again, drill in a bolt into the top of a panel, it could easily spoil off the face if it's not done properly. And again, nibs get damaged, the corners get damaged. These nibs are very vulnerable because the bottom of these don't actually have any reinforcement in them as well. And sometimes the nibs are incomplete. So what we're seeing here is the top of the panel below, and the nib is incomplete because there's a lifting eye there to allow you to lift the panel in. So we need to complete this panel by completing the nib with concrete repair mortar in situ. And remember the issue with the mold face versus the trowel face. Well, one of them got mixed up and we had a perfect mirror with all the bars in the wrong places. So the old bars were cut out and new bars were grouted in with epoxy. Can be done, would rather it wasn't done, and it takes time, delays the project. These are typical of the vertical joints, as I mentioned before, that the two panels come together and additional reinforcement is put in. In this case, it's reed bars connected into our cast-in inserts with a reed stop end as well. And then we put on a piece of formwork and cast the joint. We've also got situations where we've got panels which are cast into the slabs. Now, one of the problems with this is, of course, is this panel wasn't ready while we were wanting to cast this slab. So they had to leave a section of the slab out before this was installed, bars inserted, and that's all now cast in position. As I said, you can't always take the panel straight off the truck and into position. So you need some means of storage, and if it's a small panel, these can be on simple boards or 2x4s. But if these are larger wall panels, you need to hire one of these things, and it's like a giant toast rack for storing your panels vertically. Sometimes the surface finish that comes with the panel isn't as good as you like it to be. So the one on the left will need to be repaired. It's that surface treatment. And when you've got awkward panels like this, you often end up putting in PFC steel braces for transport and erection. Now, if this is not done properly, you can have an indent left where that PFC has gone. So that was repaired, and that was the final result, which wasn't too bad. Now we left cast inserts to put these L bars in. So the insert is cast into the panel. Unfortunately, because they're L bars, you need to put the L bars in before you put the horizontal bars in. Yes. And once you've got the horizontal bars in, you can't get the L bars in. So hence they ended up drilling them. Not ideal. So a reminder of my secrets to successful precast concrete construction. Well, the first thing is to choose a competent precast contractor, preferably one that has a technical team able to produce the shop drawings, because you don't want to produce them yourself. Checking shop drawings is a pain. It's enough of a pain as it is. Actually drawing them is even more of a pain. Choose a competent site contractor, one who's familiar with precast concrete. Simplify it. Simplify the job. So complexity in construction adds costs and it adds delays to the project. Standardize. So try to have as few different panels as you can. So standardize on the type of panel you've got and then repeat it, repeat it, repeat it. Allow those panels and the components to be interchangeable. Unfortunately, most of our panels are unique. As I said, repeat, repeat, repeat. The idea of any precast, any prefabrication is standardization and repeatability, and so that you can interchange the components. Allow for lots of tolerance. So generally, in situ concrete, you're lucky if you can get things to the nearest inch or 25 millimeters. So allow tolerance of plus or minus 25 mil. Grout sleeves, your dross back grout sleeves allow slightly less than that. but your reed grout sleeves don't. So a 16mm bar inside a 16mm reed grout sleeve leaves about 8mm tolerance on either side, and that is not enough. The construction sequence is vital, so therefore you need to plan the job and plan the sequence of construction. And this really comes back to the design. Make it easy to build. So if you do all of the above, then the building will be easy to build and you'll have fewer snags.